Micropipetters are an essential tool for every research lab in the field of molecular biology and are a super fun tool to work with if you know how to use them properly and how to take care of them. As a biology major and a research student in the field of molecular biology, micropipetters are tools that I've been using for years in classes such as cell biology and biochemistry, and they're also tools that I use on a daily basis in the research laboratory. Today I'll be telling you a little bit about micropipetters, such as their structure, their history, and why we use them in research. And I'll also be demonstrating how to use them properly to maximize their potential. As described in an article in the academic journal entitled The American Biology Teacher, the article is entitled Micropipetting, an Important Research Skill in Molecular Biology. Micropipetting instruments, called micropipetters, are an essential tool for transferring small volumes of liquid from one container to another. Micropipetters were invented in 1957 by German postdoc Heinrich Schnitzer at the University of Marburg. He grew increasingly frustrated by having to transfer tiny volumes of liquid manually using glass pipettes, so he created a prototype which utilized a spring-loaded piston and a disposable plastic pipette tip. This new micropipetter was super useful because it was mechanical, easy to use, and helped to accurately transfer liquids, and while also maintaining a very sterile environment due to the nature of the one-time use plastic pipette tip. Although the design of micropipetters has changed a little bit throughout the years, the basic principles remain the same, and micropipetters have become a tool that are used in molecular biology labs around the world. There are 4 basic kinds of micropipetters, all described based on the maximum amount of liquid that they can hold. They are the P2, the P20, the P200, and the P1000. The P stands for pipette, and the number that follows stands for the maximum number of microliters each pipette is able to use. The P2 can transfer the smallest volumes of liquid, anywhere from 0.2 microliters to 2 microliters. The P20 can transfer volumes between 2 microliters and 20 microliters. The P200 can transfer volumes between 20 microliters and 200 microliters, and the P1000 can transfer the maximum amount of volume, anywhere from 200 microliters to 1,000 microliters or 1 milliliter. Each structure of each micropipetter is exactly the same, no matter which micropipetter you choose. You have the tip and then the micropipetter itself. You can see the display for the volume, the number dial, the push button, and the ejector button. To use a micropipetter, first choose the micropipetter for the correct size of the volume that you would like to pipette. This is a P1000. First, set the volume that you would like to pipette using the number dial. Each display shows 3 numbers. This stands for 3 decimal places outside of the maximum number of volume that you're able to pipette with each pipette. Once you've set the volume, pull up on the pipette to lock the display into place so that the volume doesn't change while you're pipetting different samples. Next, fit the micropipette with the tip that is specific to each micropipetter you're using. This tip is specific to the P1000. Press it up onto the micropipetter itself and make sure it's not too loose and doesn't come off. Now you're ready to pipette. First, push down on the push button to the first place of resistance. This is called the first stop, and it indicates the exact volume that you've set the micropipetter to. Once at the first stop, insert the pipette tip into the volume you'd like to transfer out. Pull up on the micropipette push button and pull up out of the liquid the amount of volume that you've transferred out. Notice that there's some headspace. This is to make sure that the volume you've pipetted never comes in contact with the micropipetter itself. Next, transfer the volume into a new container. This time, you'll push down on the ejector past the first stop to the second point of resistance. This is called the second stop, and it's used to make sure that all the volume of liquid is transferred out of the pipette tip. Once all the volume is into the second container, place the pipette tip over a biohazard waste disposal bin and press on the ejector button to remove the tip from the micropipetter itself. Then, you can repeat this process using a new sterile tip, or you can reset the volume for a new task. It is essential when using a micropipetter to use a fresh tip with every volume transferred. This ensures that you maintain a sterile field and you eliminate cross-contamination. It is also critical to not set your pipette to a volume that is too small or too large for the pipette to handle. According to Kelly Henry in her article, How to Properly Use a Micropipetter, you should always choose the smallest pipette possible for the amount of volume that you want to transfer in order to maintain the most accuracy. Finally, it is critical that you make sure you never go past the first stop when you're injecting liquid up into the pipette tip, and always press through to the second stop when injecting liquid out to make sure that the exact amount of liquid that you intended makes it from one container to the other. Hopefully now you understand these important tools a little bit better in microbiology labs and can hopefully use them if faced with them in future science classes or in a research lab setting. Just remember, micropipetters are really crucial for maintaining accuracy and sterility when transferring volumes, and if used safely and confidently, can be really fun tools to use. Thank you.